we can sum the following notations to simplify the question, which is that T0 means that 0 is transmitted, and T1 means that 1 is transmitted. Then R0 means that 0 is received, and R1 means that 1 is received. According to the information given by this question, we can know that when 0 is transmitted, the probability should be 0.6, and the probability that 1 is transmitted should be 0.4. So PT0 equals to 0.6 and PT1 equals to 0.4. Then we can get the conditional probability that when 0 is transmitted, the probability of receiving 0 is 0.7, and when 0 is transmitted, the probability of receiving 1 is 0.3. This should be the conditional probability, that is, P when R0 happens, assuming T0 should be equal to 0.7, and P when R1 happens, assuming T0 happens, should be equal to 0.3. As follows, P when R0 happens, assuming T1 should be equal to 0.2, and P R1 happens, assuming T1 happens, should be equal to 0.8. Hold on a second. By now, we can know two things. One is that both R0 and R1 and T0 and T1, they are actually both mutually exclusive. Fact 2 is that the probability that 0 is received plus the probability that 1 is received should be equal to 1. And the probability that 0 is transmitted plus the probability that 1 is transmitted should be equal to 1 too. Then we can solve the first question. Given by the equation of the conditional probability, we know that P when R0 happens, assuming T0 equals to the intersection of R0 and T0 divided by PT0. Then we can figure out the intersection of R0 and T0 should be equal to 0.42. And as follows, the probability that R0 happens when assuming T1 should be equal to the intersection of R0 and T1 divided by PT1. Then we can figure out that the intersection of R0 and T1 equals to 0.08. Then we can solve that the probability that 0 is received should be equal to the intersection of R0 and T0 plus the intersection of R0 and T0 not happens, which also equals to P the intersection of R0, T0 plus the intersection of R0 and T1, that is 0.5. And also we can know that the probability that 1 is received should be 1 minus the probability that 0 is received should be equals to 0.52. Then the second question. When it comes to the error, there should be two conditions. Condition 1 is that when 0 is transmitted, we actually receive 1. And the second condition is that when 1 was transmitted, we actually receive 0. So the probability of the error happens should be divided into the two conditions, and we can simply sum up them. So the probability that the error happens should be equals to the probability that 0 is transmitted and at the same time 1 is received. So it should be PT0 multiplied with P R1 happens when assuming T0 happens plus PT1 when 1 was transmitted multiplied with P R0 assuming that T1 happens, and that should be equals to 0.26. That is the answer of the question 3. That's all. Thanks.